Hello, welcome to a video course on socket programming as part of inter-process communication. What is inter-process communication? Inter-process communication, or in short IPCs, are mechanisms provided by the kernel to allow processes to communicate with one another. When I say communicate, they are trying to share, synchronize, coordinate the resource or the data. If you look at this image, two processes are coordinating with one another. IPC, why? There are two main possible reasons. The first one being to inform processes that some event has occurred. For example, kernel should inform the parent process while the child terminates. The second one, to transfer data from one process to another. Um, Example, a child process needs to read the input data from its parent. So, processes can be of two types, independent processes and cooperating processes. An independent process is the one which is not affected by the execution of the other processes, while cooperating process is the one which is affected by the other executing processes. So that is the definition of inter-process communication in short. There are multiple ways in which two or more processes can communicate. To name a few, it may be a pipe, FIFO, shared memory, message queues, sockets. So each of them have their own significance. Each of them can be used in different scenarios. Today in this course, as part of socket programming, we'll see how, when, why do we need socket and how to program IPC using socket programming. Before getting into the technicalities of the socket, let me give an analogy of socket programming. Suppose two persons A and B want to communicate over a telephone network. Person A wants to make a call to person B and talk over the phone. How does this telephone conversation happen? It happens based on connection. So before actually the two people can talk over the phone, there has to be a connection established between person A and B. So A wants to talk to B. So what does he do? He dials up the number of person B, and when the person B picks up the call, that's when the communication over the telephony network gets connected and they can start the conversation. So before actually they start the conversation, dedicated connection should happen, or there must be some connection between the two people to talk over the phone on telephony network. So during the talk or during the conversation, the packets or the data from person A are kept being sent to the person B, and it continues till the conversation is continued. Once done, both of them hang up their call. So if you take this analogy and try to see the sockets in the same perspective, is more or less same. So where does socket get used is it's used in um, communication of the data between two nodes on a particular network. So two processes which are on different hosts, different machines connected over a network wants to communicate, then socket is the way. So socket programming is a way of connecting two nodes on a network to communicate with each other. So one socket listens on a particular port at an IP, while the other socket reaches out to the other one to form a connection. Similar to whenever a person wants to make a call, We need to know the telephone number of the other person, isn't it? The same way, whenever a client process wants to talk to a server process, the client process must know the address of the server process. Here, when I meant address, it includes both IP address as well as port number. So server forms a listener socket while the client reaches out to the server. So that's what in short is what is called as a socket. If you look at a basic client server model of socket communication, it look like this. On the left hand side, we have server. On the right hand side, we have a client. There are different stages through which a server program goes through, and similarly the client. The server, before it actually starts uh, broadcasting or starts uh, telling the world that, look, I am ready to listen to the incoming request, it must create a socket. Socket is a basic building block of this communication. So using a system called socket, it creates a new socket, and the bind system call is used to attach an address to this particular socket which is created. Each socket has a different descriptor, just like a file has a file descriptor, so each socket would have a different socket descriptor. So bind would attach a socket descriptor uh, with a port number and an IP address. Once a socket is ready with the address, it gets into the new stage called as listen stage, which is a blocking one. When I say blocking one, um, the server keeps listening on this particular port for any incoming request. As soon as a client request comes in through connect system call on this port number, this listen block would end and it gets into the new stage called as accept stage. And after this particular stage, now both client and server are ready to communicate over the socket. So the two processes which are running on a different systems using a socket gets attached, gets established with a connection over which they can form a communication channel. So after which they can send or receive data using this particular socket which is just created. So there are many stages of the server and the system called as just I have mentioned to go through a few main system calls. The first one is socket. So this socket system call does take three parameters: domain, type, and protocol, and returns on successful creation of a socket descriptor. It's like an integer, just like a file handler. The domain is um, it takes AF underscore INET for IPv4, AF underscore INET6 for IPv6 protocol. Type is communication type. If it is a TCP, it is SOC stream. If it is a UDP, then it is SOC dgram. This for connection oriented and connectionless respectively. So protocol is which protocol needs to be used for IP protocol, internet protocol, the value by default the value is 0. Now let's get into the next system call, that is bind system call, as part of that architecture we discussed. So after creation of the socket, bind function binds the socket to an address with a port number specified in address column, which is mentioned here as the second parameter. So this particular socket, which is just created in the previous step, gets attached with this particular address and port number. Listen, as I mentioned, it puts the server socket in a passive mode, that's in a listening mode, where it waits for the client to approach the server to make a connection. So the backlog defines the maximum length to which the queue of a pending connections for a socket particular descriptor may grow. I mean, at max, how many um, simultaneous wait processes can wait to get uh, connected to a server. So if a connection request arrive and the queue is full, the client may receive an error with indication of e-connection refute. Next is accept. This is the system call. It extracts the first connection request on the queue of pending connections for the listening socket, which is described by a particular socket descriptor, creates a new connected socket and returns a new file descriptor referring to the socket. At this point, connection is established between the client and the server, and they are ready to transfer the data. Similarly, there are a couple of stages for client as well. The socket connection is using a socket system call. It's exactly same as the server socket creation as we discussed earlier. The second one is connect system call. System call connect the socket referred to by the file descriptor sockfd to the address specified by ADDR. The server's address and port is specified in this address. That is to indicate that to which server I'm trying to connect to. That is connect system call. So that's about a brief introduction about system calls for socket IPC. Now let us see a simple problem which can be solved using sockets. Assume that I need a particular service. I need a server which accepts n numbers array and gives me the addition result of the particular array. So the client program, it wants to connect to a server and send some array of numbers, and the server should accept that particular array of numbers n numbers, add them up and send back the result to the client. Client program should display the result back to the user onto the screen. So remember, this should happen between the two processors which reside on two different machines connected over a network. So simple IPC using pipe doesn't do, IPC using FIB4 doesn't do. Here we need a certain kind of mechanism like socket, using which uh, communication over the network between two different systems on a different uh, sorry between two processes on a different systems must happen. So how do we code it? This is a simple server program. As I just mentioned, there are multiple stages to create sockets. So the first one is socket system call, using which socket is created, which returns a socket descriptor, and prepare an address, IP address and a port number, and attach this particular created socket with a particular IP address and the port number. That is done using a bind system call. Then the third stage is listen, which is a blocking call. Here in this example, there can be a maximum 3 incoming requests on which a listen can wait on, so that at the time it can take multiple 3 incoming requests. So while waiting, we put on a message to the user saying that waiting for incoming connections. On exception of incoming connection request, it moves on to the next one stage, that is accept stage. So the accept system call gets executed, so it gets connected to a particular client, and then onwards a read, a send, or a write can happen over the particular socket. In this example, what are we trying to read from the client? We are trying to read 10 different numbers. So the receive message um, would accept n numbers, right? So these n numbers are put into an array called message. So we traverse through the message and calculate the sum. Finally, uh, once we are done with calculation, we'll put back the result to the client using that client socket. The sum is put back to the client, is sent back to the client. That's a simple program uh, as part of server. Now client is similar to server. It creates a socket, then attaches an address to the socket, then connect onto the particular server and the port number. So if you remember, the same port number and the IP address was given for the server as well. Now the same IP and the port are being used by the client as well. Now what's the job of this client? Client should accept some numbers from the user and write them to the server, right? So here in this part, in this section, we are receiving 10 different numbers. Before that, we ask the user that how many elements you want to add. Now suppose he enters 4, then onwards we need to read 4 numbers from the keyboard, then send it to the server using the socket which is stored in the array. Now, once it is sent, we have to wait for the reply from the server, uh, which actually sends back the result of the addition of these n numbers. So, on receive, using receive system call, in this particular integer uh, pointer, I receive back my result. So finally, I display that to the user saying that, "Oh, look, this is my addition result." Simple, right? So how do we run it? We compile .c file socket add server.c using GCC with an option of output file server. Similarly, client is compiled using .c and -o client option. So once that's done, how to run it? So //server would make the server program to run. On a successful running, it says socket created, bind done. So by this time, on a different terminal, we run client program. So once the client is connected, it says connection accepted, then enter numbers, then we enter so many so and so number, which is sent back to the server. Server receives them, displays those numbers, sends back the result. The result of that is displayed as part of client program. Simple, right? Let us try to execute this particular uh, example of server and client. So this is my server program. So how do I run a server? I have already compiled and kept them. So I run server. So it says socket created, binding of the address is done, now waiting for incoming connection. Look, now it is waiting in the third stage, that is in the listen stage, which is the blocking call. Now in a different terminal, I run a client program. We can do this taking two different systems. Now look at this. Socket created, then connected. The moment incoming request comes from the client to the server, server also says that connection accepted. Now client is asking enter number of elements to be added. So I just give 3, then enter some 3 numbers. Look, number sent by the client, it displays 10, 20, 40, then it sends back the result and it disconnects. So sum of these three numbers is 70. So this is how two processes communicated with each other using sockets. Um, for the simplicity, I have explained this particular socket programming by running two different terminals, and on the two different terminals I am running two different processes, but these two processes can completely sit apart by a system. Server can run on one machine, client can run on another machine. Without modification, without single modification, these two programs would work exactly the same way, provided both the systems are connected through the network. I hope I cleared some points on how to program using sockets in simple terms. Thank you.